How many different four-letter arrangements are possible with the letters garden? Garden, if each letter may only be used once. Think of a tree diagram, and we can pick G or A or R, right, or D or E or N to begin with. But let's just draw out one of these branches completely. If I pick G first, the second time I could pick A, R, D, E, or N. So the first time I could have picked 6 letters, right? And the second time I can only pick 5 letters because one letter is taken up, and I could have taken any of these to begin with. But regardless, one letter will be gone. The next time, as I expand this, let's say I pick G and A. Next, I could pick R, D, E, or N. I can expand this for each of them, but here, let's just keep track that now there are 4 letters left. So first there are 6 combinations, each with 5 combinations following it, so we multiply. Each of those have 4 combinations as well, we multiply, and you can see what's happening, I think. If we had picked G and A and R, now we can still pick D or E or N. There are 3 letters left. So each of the 6 choices had 5 choices, each with 4 choices, each of those with 3 choices. And then remaining, we have 2 choices. If I picked G, A, R, D, I can finish with an E or an N, and then finally N or E, right? Here, so in this branch alone, this is one branch of many, because here you could pick 6 letters, then 5, then 4, then 3, then 2, then 1 in the end, or this is 6 factorial. The basic idea is that if you have a 6-letter word, and you can use each letter once, first there are 6 letters to choose from, then 5, right, then 4, then 3, then 2, and then 1. So you could just multiply those. On a graphing calculator, enter 6, the button Math, scroll over to the probability section, select choice 4, which is factorial, and press enter, and tell us the answer 720. You might also see 6p6, which means you have 6 letters, right? Or 5. 6 letters, yes, hence, and 6 places to put them, in the first spot, second spot, third, fourth, fifth, or sixth spot. And this is equal to, as well, you can see pick the P of 6 over 6, same idea, or P of 6 comma 6. P stands for permutation or arrangement. So this might be something you see as well. And if you see P of any N and R, where N is the amount of things you have, right? It's the item you're choosing from. And R represents the locations or the spots in which you can arrange them. There could be 6 spots, but I could say, well, maybe you have 6 letters, but you can only make a 5-letter word, then you'd have 6p5. If I said you can only use a 4-letter word, it would be 6p4, and so forth. What this equals is the amount of things you have, factorial, over n minus r, right, factorial. So this just means that you subtract the 2. The only weird thing you might get is if you see at any point a 0 factorial, that equals 1. So here with p 6, 6, you would get 6 factorial over 6 minus 6 factorial. So that equals 6 factorial over 0 factorial, and 0 factorial is 1, so it just ends up equaling 6 factorial. On the graphing calculator, you can enter 6, Math, go to probability, choice 2, and BR, and then you enter the R term, which is the amount of ways you can place the items, and you get 720 as well. Alright, thanks.